Okay. All right. Okay, so let's just get started. Sorry about the late start. We're running a couple minutes late. All right. Who am I? My name is Maggie Myslinska. I work on Windows Azure AppFabric, which is part of the Windows Azure platform, the Microsoft Cloud Computing platform. And I'm pretty excited to tell you about the product today. But before I do that, I wanted to talk a little bit about kind of the problem space and how I think about the world today. So for that, I want you to imagine a company, Big Mart. Big Mart is a large retailer. They sell anything from local goods, from local companies, to clothing. It's a Walmart, you can imagine. So Walmart, just like any other big retailer, will go ahead and build a bunch of LOB applications. Logistics, inventory, point of sale, to help them with their operations. They also work with a number of vendors and third-party applications. They have a number of suppliers, local, not local, small, big, large. And they work with third-party guys because they realize that in today's global economy, you have to work with other people. You can't be a silo to make your products more competitive, to provide a better service. And of course, when I say that Big Mart works with those guys, I don't mean that when they work with a local supplier and they run out of their shampoo, they call them up and ask for more shampoo. I'm talking about software. Both parties have software, and that software has to integrate, right? To provide that kind of seamless, smooth operations kind of experience. And now let's think about what that integration looks like. We have Big Mart, and then we have a couple of their smaller partners. So we have Loyalix. Loyalix is an online loyalty CRM vendor. So they give Big Mart the ability to provide customer programs for their customers. The more they buy, the more discounts they get, the more points they get, and so on. And then there's Maggie's Beauty Supply, just a small supplier of naturally made beauty supplies for Big Mart. They have software. Big Mart has software. That software needs to integrate. And now if you think about how exactly that comes to be, right? Does Big Mart go and work with each of those vendors and make sure that their software can see Big Mart software, that they can connect in a secure way that doesn't mess with each of those partners or Big Mart's policy, right? Do they go and talk to each of those vendors and make sure that their software can nicely integrate? Well, probably not. Big Mart is a big company. They have they work with a ton of vendors, could be tens or maybe even hundreds. Right? So you imagine what they probably would do is go through and build out probably some kind of multi-layer SOA solution with some kind of enterprise application integration software. Right? Those projects are usually very long-term. They take a lot of IT funding. They're multi-year projects, right? But once those projects are done for companies like Big Mart's, they're great. The return on investment is actually pretty good for them because once they have their applications all integrated internally within the enterprise, and once they expose some of those important applications outside of their corporate firewall, outside of their enterprise boundaries, they can very quickly choose which vendors they want to work with and get them into their integration ecosystem, right? So that's a pretty good return on investment for an application like this, for a company like that. But now if you think about what Big Mart gets and what kind of world that leaves us with as a result, right? Big Mart is the big kahuna of a company that works with hundreds of vendors. And that's great for them and great for other companies like them that realize that global economy means everybody integrates with each other. But in today's world, when we say with each other, that really means a number of huge AI superpowers that have it easy. They have their systems exposed, and they're able to work with their vendors and probably with each other. But where does that leave the SMBs, the small guys, right? They don't have the IT budget. They're not networking focused. They have some on-premise systems, right? And who will they be able to work with? Really, the only companies that they'll be able to work with are those big guys. But do they even have those kind of integration needs that the big guys do? Let's think of Loyalix, that loyalty CRM, online loyalty CRM guy. Today, with the world of big AI powers, they're only able to sell to enterprises, right? Because if they wanted to sell to someone like Olive Market, just a local grocery shop, how would they do that? They have some on-premise systems that are not exposed to the internet, right? And so what is Loyalix going to do? Are they going to ask them to go and make some changes to their networking infrastructure? Those guys probably don't even have an IT department. They have standard networking infrastructure. They have one dynamically allocated IP. All of their stuff is behind NATs and firewalls. With that kind of infrastructure, it's pretty hard to join that kind of integrated world ecosystem. So what do they have to do? And then we have someone like Maggie's Beauty Supply. What if they wanted to hook up with some local companies for a short marketing campaign? That's pretty reasonable for a couple weeks. If you buy, let's say, $200 worth of beauty supply, I'll set up an appointment with one of the local salons for you. So they want to integrate with those local salons' scheduling systems and do that right on the spot. But how would they do that? Once again, standard business networking infrastructure. That's not easy to do. So wouldn't it be nice if we lived in a world where all these different companies could just take their existing applications and connect them up to each other, easily integrate, right? Wouldn't it be nice if they could do that without even having to involve their IT department? If Loyalix could just call up one of those local companies like the Olive Market and say, easily, I just want to integrate with your application and be able to do that. Think about all the different problems they'd have to solve. Connectivity is just one issue. What about security? Right? Do they have to create some temporary credentials for them, do shared key exchanges and all those things? The Olive Market guys, who probably don't even have an IT department, they don't even know how to speak that language. So that's hard to do. If we were living in a world like that, when everybody can have their applications integrate with everybody else, small, big, or large, IT department or not, we would be in a world where all the different APIs are exposed. You could create mashups. Small companies could hook up not only with the big guys, but also with each other for short marketing projects, for campaigns, for whatever new short-term ventures. It will be a world where everybody is a lot more competitive. The global market is a lot easier to play in. That would be a wonderful world to live in, wouldn't it? Well, that's exactly what I'm here to talk about. This is the problem that the Windows Azure AppFabric team is trying to solve. Now, what is AppFabric? In one sentence, it is a way for you to take your applications and expose them out through the internet so that others can reach into it in a secure way. Okay? So if there's one thing that you take away from this presentation, I want you to think about this. I want you to remember this. If you have existing on-premise software and you want to extend its reach, because maybe you want to work with new partners, maybe you want to work with existing partners that inside of your organization or outside of your organization, or maybe you're just starting to leverage the cloud and you want to add new capabilities that are living in the cloud, but they still need to connect up to your on-premise software. If these are the kind of questions that you're asking yourself, these are the kind of things that you want to do, this is the technology for you. Windows Azure AppFabric is a set of developer services. Today we have two services. There is Service Bus, which is, the way you should think about it, it's a connectivity and messaging fabric in the cloud. Okay, I'll talk about it in a minute in detail. And then the access control service is an authorization service in the cloud with a claims-based identity model. Cool. All right, so I'll talk about Service Bus. But before I do that, I just wanted to give you a quick look at the capabilities. So I mentioned that this product allows you to do something like take an existing application and expose it out to the internet in a secure way. I have a service here on my computer. It's just a very simple service that takes an image, which is, oh. One more time. Okay, well, so it's a simple service while we're trying to figure this out there. It's a simple service that takes an image that I have on my computer that I pass in as a parameter. Actually, it's even hard-coded. And exposes out using HTTP. So what I'm trying to show you here is how I can just go to a simple browser, and you can do that yourself too if you have a mobile phone or a laptop. And you can see my image because it's exposed through a publicly addressable endpoint. So the endpoint, since I can't show that to you for this moment, it's nz.techademo.servicebus.windows.net/image. And so you should be able to just go to that image, go to that URL, and see my image. Okay. Well, so that's what Service Bus is, and we'll come back to this demo. So hopefully by then we'll figure out. Can you just go back to this slide, to the slide then? Okay. So I'll show this to you in a minute. It's running. I see it on my computer. I swear it works. But so what Service Bus is a way for you to take an existing service, like I have Service A, for example, and expose it out through a publicly addressable endpoint. So this would be something like maggie.servicebus.windows.net/service SVCA, right? So what you do is you take that existing service, you make an outbound connection, just an outbound connection to the service bus, and you establish a socket connection. And you subscribe that service at a specific service endpoint, like the one I just mentioned. And once it's exposed, you can have a client that also makes an outbound connection to Service Bus and sends the message to that URL, and the Service Bus is in charge of making sure that that message gets there. So what you see in the middle there in the circle is Service Bus. We have a set of outbound, those are the squares, outbound nodes, those are the front-end nodes that are behind the load balancer, and then a set of routing nodes in the middle. So when a service and a client come and through the load balancer connect to Service Bus, they could land on different nodes, and that's why we have those routing nodes in the middle to make sure that the message gets from the client to the service. Okay? So this is the simple case, and Service Bus has a number of capabilities that make that scenario a little more complicated. For example, it gives you the ability to subscribe a number of instances of the same service to the same service endpoint, and then when a client sends a message to that endpoint, Service Bus not only routes it, but also makes sure it gets delivered to all the different instances. Okay? There is a way to set up a direct connection between two applications that are both behind their own firewalls and NATs and potentially behind different kinds of network topologies. And actually, when I say direct connection, that's not entirely right. It's not always a guaranteed direct connection. We essentially give you a way to try to upgrade from a NetTCP connection. So once you have NetTCP connectivity established between two different applications, there is a way to do network probing to set up a direct connection, and we do that for you. And that's for improved performance, and that's a way to do peer-to-peer connectivity through the relay. The other kind of feature that Service Bus has is buffered messaging. We have a way to host a message buffer. That's what we call that feature in the cloud for you, which could listen for messages for you and hold them for you until you either pick up that message or that message buffer expires. All right? What's that? Should I try? Oh, okay, perfect. So we'll get to this in a minute. I'm a little scared to switch between computers now. Okay. Here's just a quick look at the capabilities. I think I talked about most of those, essentially. But here's just a quick look for you in case you missed some of the things I said. The programming model for Service Bus, since it is a developer service, is Windows Communication Foundation. If you're familiar with Windows Communication Foundation, you will be instantly familiar with Service Bus. So if you're familiar with the NetTCP binding with WCF, NetTCP relay binding is a Service Bus equivalent. That's NetTCP going over Service Bus. The protocol for the buffered messaging functionality that I mentioned is HTTP REST. And that's primarily for interoperability, and if you have applications where you can't install the WCF SDK, let's say a mobile device, you might not have the ability to install the entire SDK, or you don't want to install the SDK. That's a way to do that using just a standard HTTP protocol. The other thing I should mention is the integration with the Access Control Service. I know I haven't talked in detail about the Access Control Service, but that's the way we do security in Service Bus. All right. I wanted to talk a little bit about what our customers do with Service Bus today. The service has been around for a couple years now. So Service Bus came out at the same time as the entire Windows Azure platform, V1. So throughout all of our interactions with our customers, we started to notice some patterns. And so that's what I wanted to tell you about. The three distinct architectural patterns that we've seen are these three. There's service remoting, eventing, and protocol tunneling. The first one is service remoting. That's the most popular one. And essentially what service remoting is where you have a WCF service. You already had it. It's running on premise. And now you just want to expose it to the internet so that you can have one or more clients that want to communicate with that service, solicit information from it. That's pretty straightforward. Then there's eventing. And eventing it's eventing. It's where you have a client that initiates a workflow by sending a message to the service bus, and then you have one or more guys on the other side listening for that event and then responding to it in a variety of ways, potentially. And the third one, protocol tunneling, that's a very interesting pattern that we've seen a number of times, and it's very powerful. I won't talk about it in detail, but the idea behind it is it's a way for you to remote your application today with Service Bus that's not a WCF application, not a WCF service. There is a way that you can mimic connectivity over whatever protocol your application is talking using Service Bus. So I've seen personally a number of customers who sent TDS requests to an on-premise database using Service Bus. That's a way to remote a SQL Server database without having to change it. Or I've seen a number of customers that had existing simple network management protocol monitoring applications that they wanted to use once they moved their applications to the cloud, once they moved them to Windows Azure. That's a package solution. They couldn't change it, so they used Service Bus to remote SNMP requests to those machines. And so essentially the idea behind protocol tunneling is that you can wrap the protocol and the port that you're using for communication inside of a SOAP message, relay it using Service Bus, and then unwrap it on the other side. So that's pretty clever, huh? I don't have a demo today that shows you how to do that, but a colleague of mine, Clemens Vassars, he's come up with a number of demos and examples that he put on his blog. So you should go to vassars.com/ClemensV and look for a sample called Port Bridge. It's a very cool sample you can use to essentially do all of that. Remote any protocol using Service Bus. Okay, hopefully, when I switch the switch, you will see my computer. Sweet. Okay, so the service is still running, so I'll just show you that really quickly. We have the Service Bus hosted service, nztech demo, in case you can't see here, .servicebus.windows.net/image. So I should be able to see my image here in a minute. There it is. So my service is hosted inside of our Singapore data center. So your request goes out to the service bus in Singapore and comes back down and sends back that message. So here's my image. And just to prove to you that if I turn this off, you can't see it, unless it's cached, in which case that won't work. Let's try a different browser. Oh. There it is. So this is now all you can see is the feed. And that's a service that I actually forgot to mention, or a feature that I forgot to mention. It's a service registry. So here I don't have any services subscribed at any of the endpoints under my namespace, which is nztech demo, which is my account. So all you see here is an empty feed. Normally you'd be able to see a list of services that are published at my namespace so that others can discover those services. Does that work now? It's searching. Anyway, oh, there it is. Service is gone. Okay, so now what I wanted to show you is how I can take a service like this, which right now doesn't use Service Bus. It's hosted at localhost/image. It's still that same service that I had earlier, which just takes my image and exposes it out. But right now it's hosted at localhost/image. So obviously if I run it now, it's hosted at localhost/image. So I can see it, but if you go to localhost/image, you won't be able to get to that message because it's behind all the evil firewalls that are outside of my service. So if I want to make this service internet accessible, what do I have to do? The first thing I have to do is download the Service Bus SDK and then add this library. Then this URI clearly will not work because you shouldn't be able to go to localhost and hit my machine. So I have to create a different URL that's internet accessible, something like nztech.demo/.servicebus.net/ whatever my service is. And it's looking for a service namespace. This is the Service Bus library here that I'm using. So I have to configure the service namespace. My service namespace is called nztech demo. And that's all the coding I should be able to do, or I should have to do. The rest is just standard WCF. Now if I go to app.config, I have to configure Service Bus. And this is also pretty standard WCF. So right now my service is using the web HTTP binding. I want to use the Service Bus equivalent. That would be the web HTTP relay binding. Pretty self-explanatory. So I'm going to remove this binding. I also have to set up my Service Bus endpoint, my relay endpoint. And I'm going to get rid of the endpoint I was just using. I have to configure this behavior configuration, which is a way for me to do a security over the service bus transport. So this is I'm configuring the binding. Now I have to configure the behavior. And so to secure that channel, I'm using essentially a shared secret. So I'm using a combination of an issuer name and issuer secret, which I got from the access control service portal. So when you set up the namespace, that's how you secure it. That's our integration with access control. So you have to go to the portal and grab that. And now I've just hit F5, and you should be able to see the familiar URI that I just showed you. Just give it a minute. There it is. And you should see the familiar image that I just showed you earlier. And it's as simple as that. That's the way to expose an existing WCF service using Service Bus. Very minimal coding. All you really needed to do is change that URL and then make a couple of configuration changes. I wanted to show you one other quick demo. I'm not sure that we have time, but I really like that demo because it's very easy and very powerful. What I have here is a simple trace service. And it's very simple. All it does is it takes a message and it outputs it to a console. Simple service, but a very interesting application. What we've done with that service is created a trace listener. You configure that trace listener the way you usually would configure a trace listener using system.diagnostics. We included it as part of our AppFabric SDK, so you can download it, like a lot of our customers have. Because the thing that's interesting about this trace listener is that all the trace messages go through Service Bus, go through the public internet. And if you think about what environments that kind of trace listener would be interesting for, how about an environment where it's really hard to get real-time diagnostics data, like a Windows Azure environment? How many of you are familiar with the Windows Azure diagnostic system? If you are, you know that what you do is you send all the traces from the Windows Azure machines to blob storage, and then you have to wait, and then you have to download it. So if you're a developer sitting there tinkering with your application and something is wrong, you have to sit there and wait minutes, and then you make a change and you upload it again, and then you have to do that again. So not a great experience. So what a lot of our customers do is take our cloud tracer, install it or put it in with their applications in Windows Azure machines, and then the Windows Azure machines send out the traces through the cloud, and then a developer or some kind of console or monitoring application can sit on premise and listen for that data and aggregate it. So I'm going to run a couple of instances of both this and our client application. So here is, let's say, a developer listening for that trace data. Here's something like a SCOM console, like a system center monitoring solution. And here we have a couple of Windows Azure machines. So we have machine 1 and machine 2. And let's say machine 1 is having an issue, failed. Machine 2 is healthy. It's just an information message. Can you hear me? Okay. So these trace messages sent by these machines are delivered in about real time by both the developer and whoever else wants to listen to it. So something like a SCOM application. So I can send more messages, and even more. So you can have hundreds of these machines sending data, and that developer is receiving that information, and you can equip it with information on, one, what's wrong, what machine it's coming from, and it's a lot easier to debug it that way. So in terms of the service bus capability, the feature that this uses is our multicast feature, the ability to subscribe a number of services or instances of that service to a service bus endpoint. And in terms of the programming model and how you would set all of this up, it's essentially the same thing that you just saw with my HTTP service. So we grab some information from the config, which is just the path, the namespace, which is my NZ TechEd demo, the stuff you need for security, set up the service bus URI, exactly the same thing that you saw before. Set up the credentials. So it's the same thing that you saw me previously do in the config, except here it's done through code. You can do it through either. And then you set up the host and run it. And the only difference here is that in my previous demo, I used the HTTP binding, and here I have the net event binding, which is our multicast binding. That's the binding that gives you the ability to have multiple services subscribed. Great. Nope. So that was Service Bus. Now I want to talk quickly about the access control service. So I'm going to go back for a minute to my example from the intro. We learned about BigMart and their needs to integrate with their partners. We talked about the EAI project and the multi-layer SOA solution that they've created for themselves. All of this was to take care of the connectivity issue. But once they expose their services, their LOB systems to their partners, there are still a number of security questions that they have to answer. For example, how do they onboard their customers and their suppliers when they want to integrate with them? Do they have to create temporary credentials for them? Do they have to create temporary authorization rules for every system that wants to integrate with them separately? Maybe. But how great is that? That's kind of a crappy experience because they have to go talk to their IT department. That might take days, even weeks, go through all these different processes. And maybe that's okay if they work with one partner or two or five. And it's okay if they work with small guys so that they only need one account. But maybe they work with enterprises where you have a number of organizations, a number of systems that this thing wants to integrate with. What do they do then? Do they still go through and create those temporary credentials? What would be the nice case? What would be the nice scenario? It would be good if BigMart was able to just allow their customers to use their existing identities and just plug into their system. So once they're exposed and they're able to connect, just provide them an easy way to do security integration. But how would they do that? If they worked with Loyalix, then maybe Loyalix would want to use their Facebook identity because they're a small guy. If they work with an enterprise, they'd want to use their, let's say, Microsoft identity. But how would they allow them to do that? Will they have to become security experts and learn how to talk to Facebook versus how to talk to Windows Live ID versus how to talk to Active Directory? That sounds complicated. It is complicated. And very long-term. It's a long-term project to build up that kind of identity and security knowledge. And we talked about a world where the guy that wants to integrate and give this seamless onboarding experience is not BigMart with all kinds of IT budgets, but it's the Loyalix. And they definitely don't have the time or the money to become security experts. So that's the problem that the access control service is trying to solve. Access control realizes that today your identity is distributed between Facebook, between Windows Live ID, Google, your enterprise, your work identity. right? And it wants to say, I don't want to create yet another identity provider or an Uber identity provider so that everybody will buy into. It says, I want to allow you to allow your customers as a developer to use their existing identities so that they don't have to create yet another username and password, so that they don't have to worry about shared keys and certificates. So what the access control service does for you, it says, you as a developer, you just have to learn one protocol and understand one token type. And I will take care of how you talk to Live ID versus Facebook versus Active Directory. Okay? So that as a developer of an application, let's say you only understand Windows WS Federation and you understand the same old token format. But you want to allow your customers to come in with OpenID. As long as you say, as a developer, that you trust those identity providers like Facebook, access control will allow your customers to go to Facebook, grab a token from them, bring it to the access control service, run it through a rules engine for rules that you've previously set up for them, create a different token, and return that token for whatever token format that you understand back to you, and then you can make the authorization decision. So that's the idea behind access control. Does that make sense to everyone? The idea of single sign-on in the browser has been around for a while. That's what we're trying to accomplish. That's one of the big features of this service. If you have heard of access control service before, and you know what we have in our production environment today, I just wanted to quickly walk through what we had versus what the V2 of Service Bus, which is what we recently added, looks like. The V1 of access control in our production environment today enables you to do some pretty simple things, such as create a specifically REST web service and secure it using tokens issued by the access control service. And their access control can take identities or tokens from a few different identity providers, including Active Directory. We can integrate with Active Directory. But we don't have things like support for websites. We just added that recently in our labs environment. I'll talk about production versus labs in a minute. But essentially what that means is that today, the service that has support for a website, has a nice developer experience, a management service, that service today is in labs with no SLA. Obviously, that's only today, and we'll move that to production, but I just wanted to make that clear. I wanted to do a walkthrough just so you're super clear on exactly how this works, so there is no magic. We start with the BigMart resource, some kind of service or application that they're trying to secure, protect. We have BigMart's access control namespace. This is their account that they've created with the access control service. They can do whatever they want with it. The first thing you have to do is establish trust between your application and your access control namespace. Then you have your partner that wants to integrate with BigMart's resource, wants to access it. The first thing BigMart's administrator has to do is set up a set of access control rules to say who has access to which resources and create a number of rules that describe those scenarios. Then we have the identity provider, so maybe Facebook for Loyalix. You have to go and establish trust between your namespace, your access control namespace, and that provider to say, my application will allow my customers to use this and that identity provider. So maybe Facebook. Once that happens, that's the configuration portion. Loyalix can go to Facebook, grab a token. The token gets returned, and then sent to the access control service. That token contains a set of claims about Loyalix, that user that's trying to get to that resource. So it's like a business card. I present you with my business card, and it tells you a bunch of information about me. That's what that token contains. Access control takes that tokens, runs it through that rules engine that I mentioned, and returns a different token. The token that your application understands. And then Loyalix can present that token as part of a payload message that it sends to your resource. You do some validation, and then you allow that access, or don't. So that's the idea behind access control. So now I wanted to go through a quick demo where I can show you how you can create a simple website and how you can integrate that kind of access control experience into it. One of the features that we've added recently to access control is support for Windows Identity Foundation tools. You might have missed that in my V2 slide. So what that means is that with Windows Identity Foundation, you can create this kind of seamless onboarding experience without any code, and that's what I want to show you. Just a minute. So this is just a simple application that's hosted on my computer, and this shows you I've previously logged in using my Facebook identity, and this goes to our labs environment. So it looks like it's having it's taking its time pulling up my images, but this should be Google and I believe maybe Active Directory that I've added. Actually, I'm going to log in with my Facebook identity. But what you saw there is just a simple portal. It's just some HTML that the access control service hosts for you. You can link to it and provide this home realm discovery experience, that's what we call it, for your customers, and not have to do any coding. So I'm going to log in here using my Facebook identity, and that'll take me to my simple website. And that shows you up here who I am and who just logged in. So that's what I want to show you how to do. So what I'll do is just create a simple website that doesn't do much. Let's create an MVC application. It's fine. MVC application 4 is fine. I don't need any unit tests. And what you'll see is essentially what I just showed you in a minute, which is just the default MVC application. If you've played with MVC before, you would have seen this. So here I haven't done anything, so if I click on log on, I haven't implemented this. It's asking me for username and password, but obviously nothing will happen because I just created this project out of a template. Okay, so how do we get from what I just showed you, which was the same application that allowed me to log in with Facebook, from this? Well, the first thing you have to do is go to our portal page. It's portal.appfabriclabs.com. I'll log in with my Live ID account. I've previously made an account, and it's a very simple process to create one. And because it doesn't have an SLA, it's free, so you can go and start playing with it. So I have my Live ID account associated with it. I created a project name, ACS demo. When you create your account, it asks you to create one. And I already have one namespace that I use with the project you just saw. So I won't delete it. I'll just add a new one. So you just create a simple create a namespace. Let's call it NZ tech ed demo. Let's make sure that no one took this. That would be sad. Normally you'd be able to pick a region here, wherever our services are available. But since it's our labs environment, it's only available in the US today. So I'll create one. It's activating. Just give it a minute. Great. And now I'll have to configure the access control service for this namespace. The access control team, I don't work on it, but I'm very proud of them with what they've done with this portal, because it gives you a very simple step-by-step process for setting up this kind of experience. So this is our labs environment, and combined with the pretty slow network here. This is taking a little longer than I would hope. But here's just a step-by-step process for what you need to do to set up the access control service for a namespace. So the first thing you want to do is, I don't know if you remember in my interaction walkthrough, you need to specify which identity providers you want me to be able to log in with. So by default, you have Windows Live ID. Let's add Google. And here it'll ask me if I want to give it an image that'll show on that portal that I showed you. I don't have an image from the top of my head, so I won't add one. Let's add another one. Let's also allow you to log in with your Yahoo identity. I showed you how Facebook works. Let's create a couple of these. So those are the identity providers that my application will trust. The second thing I need to do is configure a relying party, which is my application. It's the application that the access control service will generate the tokens for. So it'll be localhost, because my application will be hosted locally, and let's call it 9,000. So name, or let's make a prettier name, ACS demo. My URL, return URL. Let's give it, these are the token types that access control supports today. Let's give it SAML 2.0, and the rest let's leave as default. You have to create a new rule group, and a rule group that's a set of rules that are associated with that application. Okay? So I created a new rule group, but now I have to go and configure it. So you can go through the manual process and generate a set of rules which essentially tell you which claim types, would be something like username, right? Which claim types get passed with through the access control service to your application. I'm just going to create a default rule group which will take all the claim types and pass them to my application. So that's what I'll do. And here you have, in a second, you'll see these are my rules. So you'll see all the different claims are being passed through. And there are a couple of pages of this. So I'll save this, go back. Okay, now I need to set up the security for assigning my tokens. So you can use either a shared key or a certificate. Let's call it simple. Oh, there it is. I've done this before. Token signing, and I happen to already have an X509 certificate, so I'll just go and get that. Sounds simple, ACS cert. Put in my password. And that's all you need to do. That's all you need to do for this setup. So pretty simple. Just walk through, and it'll tell you exactly what to do. So now I'll go to my MVC application, and I have to do a couple of things here. The first thing I need to do is make sure, where are properties? that I don't use just the generated port by default, but a specific port, because that's what I've configured. So I believe I've configured port 9000, I think. So we got to give it port 9000 and make sure that's the one it uses. The second thing I have to do is set up the trust between my application and my access control STS. So because I've already installed Windows Identity Foundation as part of the SDK, I have this handy little tool here, which is the federation utility that I can use to set up that trust. So it's asking me for my application URL. So my application is localhost port 9000. Just go through the wizard. It's telling me my application is not using SSL. That's okay. This is just a test application. You probably wouldn't want to do that otherwise. So I want to use an existing STS. And for that, I have to go to my access control portal and get the WS Federation endpoint that access control hosts for me. So it's right here. So I'll just grab this URL, go back to my wizard, put it in, and just to test it and make sure everything works, that it can actually see it and have access to it. And that should be fine. There it is. Next. No encryption, claim types, summary, done. There is one other thing I have to do. Because this is an MVC application, it doesn't have anything to do with the access control service. I have to change the ASP.NET runtime here. The request validation mode. And I just have to change it to 2.0. Make sure that works. Okay, that should be everything. So now if I run this, hopefully we should see the same thing that you saw before, which is this portal that access control service hosts for me. And now I should be able to just log in, let's say with my Google ID. I can pick any of those because my application should trust it at this point. And log in. So the interesting thing about that portal, obviously it's not the greatest experience. It's not customized. It's just a blank page that the access control service creates for me. We do give you a way, allow, to one, customize that page. And two, we give you a way to just grab that HTML from the portal and embed it as you wish. This is just the simplest way to do it. It's just a link that I embed in my application using WIF. And that's the easiest, fastest way to do it with no coding. And there it is. So I logged in, it took my claims, it's able to expose it out on the page. As simple as that. So just so I can show you I wasn't lying, I'll go back to the integration pages to show you where you can look. Ooh, there it is, for login pages. Application integration, login pages. ACS demo is my application. And this is the URL of the portal that you can embed in your application. We also give you a JSON feed that gives you all the information about identity providers and rules. So you can create your own, or you can download the sample login page, which will give you all the JavaScript and HTML, even including our CSS page. So you can just put that in your application and make your own. So that's the access control demo. I wish I could show you more, but we're running out of time. Just quickly walk through the rest of the presentation. Like I mentioned, I don't work on the access control service myself. But here are just a couple of resources. where you can go and find out more. This is our portal where you can get started, portal.appfabriclabs.com. Go and download the SDK because it's not part of our production supported product today. Probably the best resource and with all the samples in the SDK can be downloaded from acs.coplex.com before we port it over to our production service. Besides the Codeplex page, probably the best resource to go and find more information from is Justin Smith's blog, who is the program manager working on the access control service. And his blog is blogs.msdn.com/b/Justin Smith, Justin J. Smith. So he has a lot of good information about the roadmap and some samples and documentation on his blog, so you should go and check that out. Environments. Like I mentioned, we're a services team, so we put out features in 2 different places. Production, that's SLA. We tell you what you should expect out of the service, and you should expect a lot. And if we don't adhere to what we told you, then monetary compensation goes back to you. That's what having an SLA means for us. We put out new features about every 3 months in both of those environments. They usually go first to the labs environment, which doesn't have an SLA. And then once we get your feedback, or we keep working on the performance, and once we decide that that feature is up to par for production, we move it over. If we hear from you, you don't like it, you're not interested, then they might just never make it there. That's how you should think about it. The roadmap, you saw the V2 of the access control service just made it to labs. Soon you'll see that for the service bus as well. There's a big conference coming up on the Microsoft campus soon in October. That's a hint. You might see some new things then. We will be adding some advanced messaging capabilities. We want to add durability. We want to add failover, load balancing, and integrate with our partners more closely so that you can do things like expose a service out of BizTalk, for example, easily using Service Bus in a secure way. And more long-term, we want to add additional protocols, both with the access control service and Service Bus, so we don't have such a huge dependency on Windows Communication Foundation, and become more interoperable as well. And then always improving performance, improving scalability, and so on. And in the future, you might also see other integration features like workflows and transformations that we'll be adding to Service Bus. Pricing. The billing meter for Service Bus is connections, and the way you should think about a connection is that it's a connection between your application and Service Bus. So if you have a client to service connection, that's 2 connections the way we think about it, because it's your application, Service Bus, your service. Okay? And what we actually charge for is connection months. So the $1.99 for an individual connection, so if you don't choose to prepay, that's what you pay. Or if you pay $3.99 if you don't choose to prepay through one of our offers, Windows Azure offers. What you pay for, the $1.99, is a month of using a connection. Okay? So if you only use it for a day, you don't pay $1.99, you pay $1.99 over 30. Okay? And the other thing that you should think about is that the way we calculate our connections is we split up a day into 5-minute intervals, and we take the interval in which you use the most number of connections. So that's a nuance that a lot of people don't know about, and it's a bit complicated. But it's a big help if you have very spiky load. Okay? So split up the day into 5 minutes, and then pick the one where you use the most. So let's say if you used only 5 connections in a 5-minute period of time in a day, we'll charge you 5 connections for the day. But if you use consistently 1 connection throughout the entire day, that's also 1 connection. Support, just like with any production service, you'd expect support. So obviously, we have that as well for both billing and for development for a live site. Global presence, we co-locate with Windows Azure, so you can expect our services to be wherever Windows Azure goes. We're in every data center that they are in today. Sign up. Go to Microsoft.com/Windows Azure/offers. Those are the offers that I mentioned earlier. If you know what your usage of the services will look like, if you can predict that, you should go ahead and sign up for one of the packaged deals. We have a number of offers that you can read about through this website, where you purchase a little bit of everything inside of Windows Azure, and then you get a discount. So that's a good deal. Download the SDK, try out the samples. All the samples that I showed you today, all the demos that I showed you today, in some capacity are included in our SDK, so go and try it out. Please complete an evaluation form, and now I'm going to open up to questions. And I think we only have a couple of minutes, but I'll go and hang out in the lounge to get your questions.
So you had a bunch of identity providers. Can you roll your own identity provider?
Yes. So I don't know if you noticed that I had a number of protocols like OpenID, and then I had a number of identity providers. So the reason why I put those identity providers there is because those are the identity providers that we have first tier 1 support for. Those web identity providers specifically, they're included in our portal. But as long as you have an identity provider, create one that supports one of those protocols that I mentioned, like OpenID. So Yahoo implements OpenID. Right? So we support that as a tier 1 identity provider, but if you have an identity provider that supports OpenID, you can also use that. That happens at your application layer. Right, yeah. So when you create rules, you do things like if, let's say, if you do Active Directory Federation, if your email looks as such, then your role is administrator. And then your application says, if claim type is role is equal to administrator, then do this. So it's up to your application. And so you can create them either for groups, like you're saying, or for individuals. So the default one that I created just allows everybody to do everything. Don't do that. Oh, question there?
So does the abstraction of the third parties extend out to web services as well, so when there's no UI, or can third parties also still have to know how to code to Google, for example, get a second code? Is that being abstracted for us? Or?
I'm trying to think if I understand the question. So oh yeah. That's right. Yeah. You can also do that. So the UI is just a nice thing that we do for you to get you quickly up and running. If you don't want to write any code and you want to embed that in your application, this is just what we consider our first tier support for websites. But you can also do that in a RIA application because we host a client access policy file for you. You can do that with web services as well.